So now how much I can measure in the main branch? 100 amperes. Before shunt, how much I can measure in the main branch? 1. That means the range has been increased how many times? That is the range. The range is given by the formula I by Ig, where I is the main branch current, where Ig is a galvanometer current. So that is the range again. Clear for everyone? So what is I by Ig now? G plus S by G plus S by, yes, that is a range N. N is a range. So from here, what is shunt we have to connect? G by N minus 1. Very, very important formula. Again, I'm explaining, listen carefully, a very simple concept. Initially, there is a galvanometer, assume there is a galvanometer, only a galvanometer. So in this galvanometer, maximum, I can allow a current of 1 ampere. If I allow 1 ampere of current, that means all the 20 divisions it will rotate. That means maximum how much it can measure? 1. If you send more than 1 ampere, also it can't measure it. Now what I am doing to increase the range, that means to increase the amount of current I can measure, I am connecting a shunt. As soon as I connect a shunt, the shunt is very, very small. If the galvanometer is some 500, the shunt I will connect as 0.1. Very, very small resistance. If resistance is small, then current will be maximum. That means even if I am sending 100 amperes of current, only 1 ampere will pass through the galvanometer, or remaining 99 will pass through the shunt. That means initially this galvanometer can measure a maximum 1 ampere, but now as soon as I connect a shunt, it becomes an ammeter. In ammeter now, how much it can measure now? 100. That means what is the range? I increase the range of the ammeter from 1 ampere to 100 amperes. That means the range has been increased by how much? Range is 100 by 1. That is how much? 100. That how to find that range? To get this range, what is the shunt you have to connect? The shunt is given by the formula G by N minus. Clear for everyone? Another formula for range. New divisions by old divisions. New divisions by old divisions. Initially, I'm sending only galvanometer. Only galvanometer is present. Now I'm sending some current. Now it is showing me some 20 divisions. Now I connected a shunt with the same galvanometer. Now I connected a shunt. As soon as I connect a shunt, the galvanometer is showing me only 2 divisions. Understood? Initially when I'm sending 1 ampere. Now also I'm sending 1 ampere. But initially it showed me how many divisions? 20 divisions. But now I'm sending 1 ampere. Some current will pass through the shunt. Now it is showing me how many divisions? 2 divisions. That means the range has been increased by many times. Now what is the maximum? Here I for 20 divisions I can measure 1 ampere. Yet with 2 divisions only I'm measuring 1 ampere. That means what is maximum current I can measure by using same ammeter galvanometer. For 2 divisions 1. For 20 divisions how many we can measure? 10 ampere. That means the range is how much in this case? Old divisions, new divisions how many? Okay, wait. Old by new. That is 20 by 2. That is how much range? The range has been increased by 10 times. So if you didn't understand, remember that formula enough. So galvanometer is a device which can measure the current as well as which can measure the voltage, but small amounts. For large amounts, we cannot use it. So for that purpose, what I am doing to measure large amount of currents, I am connecting a shunt. As soon as I connect a shunt, in the branch I can send 100 amperes now. Initially it can measure only 1 ampere, but as soon as I connect a shunt, 1 ampere is passing through galvanometer, but 99 is passing through this. So what is the range has been increased. In the main branch, I can measure up to 100 amperes. That means the range has been increased. What is the formula for range? I by Ig, which is also equal to G plus S by, yes, simply the shunt is given by the formula G by N minus. If you break ammeter is simply galvanometer, ammeter simply stunted galvanometer. That's all. Understood? Very easy, clear? Next one, voltmeter. Now, what is voltmeter? Even the galvanometer is also can measure a maximum of voltage. So, this is a galvanometer. some current passing through it, Ig. So what is the voltage drop across this galvanometer? The voltage drop across this galvanometer means simply current passing in it, that is Ig into galvanometer resistance. That is the voltage. But it can measure only small amount of voltages. But now I want to measure large amount of voltages. So for that purpose, what I will do? This resistor X. Listen now. I connected a galvanometer. Now initially, what is the maximum voltage the galvanometer can measure? That is Vg. Than that it can't measure. Understood? But now, to increase the range, what I am doing? To increase the range, I am connecting a resistor in series with the galvanometer. A resistor, a series resistance. To connect to an ammeter, I will connect a shunt. But to convert into a voltmeter, I will connect a resistance, a large resistance. This is a very large one. Okay. Now, initially the voltage is how much? Ig into G. But now what is the voltage? Now it can measure. In this one, the current is Ig only. Now what is the voltage it can measure now? Ig into G plus R. This combined R plus galvanometer. This combined is known as a voltmeter. Understood? So now simply the range. The range is how much? V by Vg. That is the range. So the range to get that range, the resistance has to be R is equal to G into N minus 1. Right formula. Remember it. The ammeter has to be connected in series or parallel. The ammeter has to be connected in series or parallel. The ammeter has to be always connected in ammeter. Always it has to be connected in series. If you connect in series, then only we can measure the current. And for ideal ammeter, what must be the resistance? For ideal ammeter, the resistance has to be 0. But for voltmeter, how the voltmeter has to be connected? Parallel to the resistor. And for an ideal voltmeter, what must be the resistance? Infinity. If the resistance is very, very large, then no current will pass through it. All the current will pass through the resistor X only. That means like in the current, the voltage what we are getting will be a correct voltage. Understood? So to get the correct reading, the resistance has to be very, very large. That means infinity. Then no current will pass through this. There is no current passing through this, then I will get the exact voltage. If not, if R is in a limited value, then some current will pass. That means the voltage across X is not correct. So to make it correct, what must be the resistance has to be? Very high resistance. That means in this the voltmeter, what must be the current has to be? Approximately 0. Or if you didn't understand anything, just remember the two formulas. To convert a galvanometer into ammeter, I have to connect a shunt. What must be the current shunt value? G by N minus 1. To convert a galvanometer into voltmeter, I have to connect a resistance in series. What must be the resistance value? G is equal R is equal to G into N minus. Simple logic. Take one small question on this one. We'll wind up the class. Not class, topic.
So can you once again show that the voltmeter?
This
Yes, sir.
combined is known as ammeter. Shunt plus galvanometer. This combined is an ammeter. Shunt galvanometer plus resistance. This combined is known as a voltmeter. Voltmeter has to be always connected in parallel, whereas ammeter has to be always connected in series. What is the purpose of connecting this shunt and this resistor? The main purpose is to increase the range. Usually, only galvanometer can measure small amounts, but to increase the range, I am connecting the shunt and resistor. What is the meaning of range? Understood what is the meaning of range? Only galvanometer can measure a maximum 1 ampere. But as soon as a current is sent, in the main branch, I can how much of current I can send? 100 amperes. Understood? That means now range has been increased from 1 ampere to 100 amperes. That means range has been increased by 100 times. Okay. Take the question, Ra. Whose mobile is that? Okay, take the question. Take the question, everyone. The maximum current of a maximum current of 0.5 milliamperes, a maximum current of 0.5 milliamperes can be passed through a galvanometer of resistance 20 amperes, so 20 ohm. Maximum how much of current you can pass through a galvanometer? 0.5 milliamperes. Than that it can't measure. Now, find how can we convert into first one ammeter of range 20 amperes. Second one to voltmeter of range 50 volts. This is a galvanometer. So what is the maximum current I can send through the galvanometer? 0.5 milliamperes. Now I want to convert into ammeter. So what is the ammeter I have to measure? The ammeter has to measure a maximum current of how much? 20. That means first one. Initially the galvanometer current is 0.5 milliamperes. But now the same galvanometer, if as soon as the current is 10, it can measure up to how much? That means what is I? I is 20 amperes. What is the range? I by Ig. That is how much? 20 by 0.5 into 10 power minus 3. That is how much? 20 into 10 power 5 ones, 5 fours. That is 4 into 10 power 4. That is the range. Otherwise, wait. 20 ampere is very large value. We'll take some other value. What you will take? 1 ampere. Initially, it can measure how much? 0.5 milliamperes. But now how much it can measure? So that means range is how much? 1 by 0.10 power minus 3. That is how much? 10 power 4 by 5. That is 2 into 10 power 3. That is the range. For that, what is the shunt I have to connect in parallel? The shunt is given by the formula G by, that is 20 by 10, 20 into 10 power 3 minus 1. That is 20 by 2 into 10 power 3. Approximately how much? 20 by 0.01. So if I connect a shunt of 0.01 ohm, then I can measure a current of how much current? 1 ampere. Right, 2000 minus 1 is approximate 2000 only. Okay. Clear for everyone? So if I want to convert into voltmeter, now you say me 5 volts. Now if I want to convert to voltmeter, then what is the VG? Initially, what is the maximum voltage the galvanometer can measure? Ig into G. That is 0.5 into 10 power minus 3 into what is the galvanometer resistance? 20. That is how much you'll get. Initially, what is the maximum voltage is the galvanometer can measure? 0.5 into 10 power minus 3 into 20. 10 power 4. Right. 10 power minus 2 volts. But now what is the maximum voltage it can measure now? 5 volts. So what is the range? Range is V by Vg. That is 5 by 10 power minus 2. That is how much? 500 is the range. That means the range of the galvanometer has been increased by how many times? 500 times. To increase the range 500 times, what must be the resistance you have to connect? G into That is 20 into 500. Approximately how much? 10 power 4 ohm. Or 9,999. Is it clear for everyone? Sometimes instead of giving you Ig, they will give like this. The galvanometer is having 30 divisions and the current sensitivity of the galvanometer is 1 division per, or we can write like this, 1 milliampere per division. Understood everyone? So instead of giving you directly Ig, they'll give like this. A galvanometer is having 30 divisions, and what is the 1 division gives me how much of current? 0.1 milliampere. That means 30 divisions means how much it can measure. 30 divisions means how much current it can measure maximum. 30 milliampere. That means Ig will be 30 milliamperes. Understood? Okay, this is last year same syllabus paper. We'll solve these questions. Same current electricity and this one. Same paper. Once check whether you can solve it or not. I want to know whether you can solve it or not. For exam syllabus is done. All any good problems are there, I'll discuss in next class. I thought to discuss today first 1 hour. I thought to discuss this, and remaining 2 hours I thought to give some good problems, but no time. Approximately, I want to know whether you can solve it or not. That's all. Check and say me. First question, can you solve? Online students, once check it whether you can solve it or not. This is first one. I want to find the magnetic field at the center. Hey, listen. I want to find the magnetic field at the center. So how many parts I can divide? First part, second, third, and fourth part. 1, 2, 3, 4. Because of first and second, because of first and third, what is the magnetic field at the center? 0, because it is along the line. And because of second, what is the magnetic field formula? Semicircle. Mu naught I by 4 R or pi R? 4 R, not pi R. 4 R. And because of this, the current is magnetic field is inwards or outwards? Outwards. Because of this part 4, you say me what is the magnetic field? Mu naught I by 4 of 2 R, 8 R. And the magnetic field because of that one is also outwards. Simply add them. Easier, I think you can solve it. The second one you say me now. I want to find the potential difference between the points A and B. About this point A and about this point B. So now what we can do? First of all, I am going to convert into simple circuit. Listen. This is a cell. 2-volt cell. Connect with a resistor of how much? 15 and 15. Okay. So now what is the current in each branch? The current in each branch is how much? 15 by 2. That means the current in this branch is 15 by 2. Any doubts? Understood? In this branch, 15 by 2 amperes. In this branch also 15 by 2 amperes will be there. Because these two resistors are in parallel. Can you see them? Now I want to find the effective resistance only across A and B. So KVL. So VA, the overall resistance here is how much? 10. So 10 into what's the current is equal to VB. That is how much? 15 5 is Array 2 by 15. Current is 2 by 15. So 2 by 15. Now you say me 2 2s, 2 3s. That is how much? 4 by 3. This one is saying question number 3. Two galvanometer coils, each of resistance 10 ohm and full scale deflection is how much? 10 milliamperes connected in parallel. Just now we did. So what is to convert into a which one I want? Voltmeter. So initially what is the maximum current can make? 10 milliamperes. What is the resistance? 10 ohm. That means what is the VG? 10 into 10 power minus 3 into 10. That is how much? 10 power minus 1 volt. Now what is the maximum voltage it can measure now? 5. So what is the range? The range is 5 by 10 power minus 1, that is 50. So once you got the range, what is the resistance you have to connect? G into n minus 1, that is 10 into 49. Approximately how much? That's completed. Question number 4, check once we can solve or not. I want to know just we can solve or not. No problem. Galvanometer resistance, no problem. Now same here now. I want to know whether you can solve it or not. You can solve at home. Just I want to know. Same here, current carrying wire of length 1 meter is folded in a circular form. How many circular turns would produce the maximum magnetic moment? The maximum magnetic moment is given by the formula NIA. So now say me. So when the magnetic moment will be more? The magnetic moment will be more. N is the number of turns into I into A. Even if I made into single turn, even if I made into 100 turns, the current value is same or different? Current won't change. Now, same length is there. So length is how much here? Assume the number of turns are N1 or N is the number of turns. The resistance is how much? The radius is how much? R. That means the length of the wire is same. Length of the wire is how much? 2 pi r into N. So what is the area now? You say magnetic moment is NIA. Area is nothing but pi r square. In place of N, what we can write? In place of N, what we can write? L by 2 pi r. R cancel out. That means what we can write? I pi cancel out. IL R by 2. Understood? That means the magnetic moment is directly proportional to R. That means if radius is more, the magnetic moment in this case will be more. When the radius will be more? When the number of turns are 1. See the 8th question. Just I want to know whether you can solve or not. Check it. Two long wires A and B are parallelly separated by 10 centimeters and they carry a current of 10 and 50 amperes in the same direction. In the same direction means it is attractive or repulsive force, right? Attractive force. The magnetic force between the 2 meters length is how much? What is the formula for magnetic? What is the force? Mu naught I1 I2 by 2 pi r into length L. Length of 2 meters. So what is magnetic force formula? Mu naught I1 I2 by 2 pi d into length L. Clear? Right? Formula based. As the current direction is same, it is attractive force. This question I think this one also gave in the notes. So in which direction the circular path will be now? So by using Fleming's left hand, you will say what is the direction of the force? Magnetic field is inside. The velocity is this side. This is the direction of the current. Velocity is that side. So the force is in which direction? The force is in which direction? The force will be somewhat in this direction. This is the direction of the force. That means this is the center. So if there is a circular path, now you say me. If there is a circular path, somewhere here the velocity is approximately. The force is somewhere towards the center. That means this is a path it can cover. That means it will cover like this and it will start to go. Understood? So now you say me at the center what is the angle made? 45. This has to be 45. This is 45. This has to be how much? 90. That means T by 4 is the time taken. For how much angle it has been rotated in the magnetic field region? It has been rotated only by 90 degrees. That is T by 4. For time period, 2 pi m by bq by 4. That is pi m by 2 bq. In option is the third option. These two, once they check 5th and 6th, check it. If the area of the conductor is increased by 1%, then the percentage change in the resistance would be by remolding it. Always remember remolding. Remolding means same material. There is no extra material. That means volume is constant. If the volume is constant, then the resistance is directly proportional to L square, or it is inversely proportional to A square. So what is the resistance? The resistance delta R by R is how much? 2 into delta A by A. So if the resistance is, so if area is increasing, minus, the resistance will decrease by how many times? 2 times. Right, do you remember? Delta R by R is minus 2 into delta A by A. As in denominator, minus. So if area is increasing, then the resistance has to decrease. Clear for everyone? Ninth question. Ninth question. Check it whether you can solve it or not. Two batteries. One of the EMF is 18, another one is 2. Simply these two connected in series or parallel? Parallel. They're asking what is equivalent EMF. So what is equivalent EMF? First of all, what is R equivalent? R1 R2 by R1 plus R2. That is how much? 2 by 3. So what is E equivalent? E equivalent by R equivalent is equal to E1 by R1 plus E2 by, both are having same connected. So plus plus. So how much you will get? E equivalent by R equivalent is 3 by 2 into 18 by 2 plus 12 by 1. Approximately how much? 9 plus 12, that is 21. So 3 ones, 3 sevens, 14 volts. So what is voltage across it? How much voltage? $14 volts. Any doubts? Simply cells in parallel. 10th question. 10th question. It's a regular hexagon shape. Find the expression for the magnetic field at the center. If it is a regular hexagon, you say me no. First of all, I'm going to find only magnetic field because of one wire. If I find the magnetic field because of one wire at the center, now you say Mira. So the length is assume L. Side is A. So now, what is the angle made? It forms at the center, they forms equilateral triangle. So what is the distance? The distance is important. The perpendicular distance is how much? Very good. Median root 3a by 2. And what is the angle made at the center? One end. This angle is 30. That angle also will
30
be
degree, 30 degree.
This is the side. This is the center. This is the root 3a by 2 is the distance. One angle is making alpha. Alpha is 30. Other angle is making alpha. That is also 30. What is the magnetic field now? Mu naught I by 4 pi root 3 by 2a. D is root 3 by 2a. Sin alpha plus sin beta. Alpha is 30. Beta is also 30. 1 by 2 plus 1 by 2 is 1. Like this, how many loops are there? How many sides are there? 6. So how much you will get? 2 ones to 2s. 2 ones to 3s. Root 3, root 3. Root 3 is remaining. Completed. 11th question. This one also I gave in the notes. There is a loop of resistance. How much? What is our resistance? 18 ohm. So now 160. If it is 160, the remaining is how much? 240. That means if this is resistance R, then the remaining resistance will be how much? 2R. That means if this is 6, the remaining has to be how much? 12. Both are in series or parallel? Parallel. So what is equivalent resistance? 12 into 6 by 12 plus 6. That is how much? 18. 3. 4. Completed. Notes question. 13th question. 13th question. Tell me whether you can solve it or not. What I want to find. In the circuit shown below, the net power dissipation across all the resistors is how much? Now what we can do? I want to find the net power dissipation across each resistor. Now say me. This may be a little bit lengthy question. Try it and say me. Do it in the notes. Array in whole paper, maybe out of 25 questions, maybe 3 to 5 questions will be difficult. Even if we can solve remaining 20 questions properly without mistakes, you'll be in top colleges. Or even if we can solve 60 out of 25 questions, even if we can solve 15 questions, don't bother about remaining 10 difficult questions. That bother about that easy 15 questions. 60, 60, 60. You'll get how many marks? 180. One easy subject will be there. In that, if you got 20 marks extra, then it will be 200. 200 means you will get Trichy. Top colleges you will get. Easy to get. No need to struggle. Even if we can solve 50, 60% easily. Even if you can solve 15 questions, even if you left 10 questions in each subject, you will be an idea. Simple. Don't make complicated. Only thing is you have to do without any calculation mistakes. I want the answer now. Do it. Tomorrow, next week, when you're writing exam, I want everyone to revise the notes and then write. Last week also many members here not even revise the notes. So revise the notes whole week. Spend revising the notes thoroughly and then you write the exam. 90% will come from the notes. Maximum I covered. Maybe if I left 1-2 questions, okay. But maximum concepts I covered. So revise the notes. Be perfect with the notes. Easily you can score 80 to 90%. Revise the notes. Revise the notes. Revise the notes. So now say me. So I'm assuming like here now. I'm assuming in this one the current is I1, in this the current is I2, In this, the current is I3. I don't know what is the current. I'm assuming. Okay. Okay, like this, I'm assuming. I1. This is I2. This is I3. I'm assuming like that. So now you take KVL. Now you take KVL. I'm starting assume A. VA. Listen now. VA. I'm moving from positive to negative. So minus 2 or plus 2 ara. Again from positive to negative. Minus 2. Again from positive to negative. Minus 2. Current direction, my looking direction same. So much. Minus I3 into 1. Again moving from positive to negative. Positive to negative means my positive to negative. Minus 2. Again from negative to positive. Again from negative to positive. Equal to how much? VA. So minus 2 plus 2 cancel out. So what is I3 ra? I got in this ratio the current is 4 amperes. Understood now? Clear? So same. I'm assuming in this the current is I2. I don't know what is that I2. So I'm assuming. So again start the KVL. VA minus 2 minus 2. Current direction and looking direction both are same. So minus I2 plus 2 plus plus 2 are plus 2 equal to VA. Plus 2 plus 2 plus 2 minus 2 cancel. What is I2 value? That means in this one what is the current? 0. I am taking one big loop here. VA. I'm taking one loop. Then second loop. Then third loop. Understood? So take the third small loop. How much you got? VA minus 2. In this one, I'm assuming the current is some I3, I1. So minus I1 plus 2 equal to VA. So what is I1? So in this one, the current is 0. In this one, the current is also 0. That means in this one, last one, what is the current? 4. So what is the power dissipation? I square into R. That is 4 square into 1. That is how much? Silly questions. Clear for everyone? This one you say me, no? I have to study that RC circuit also. The RC circuit actually comes in current electricity. Okay, now same, you know. Now, I am converting this one into a simple circuit. Listen now. And negative is connected with negative. Positive is connected with positive. Okay, now they are in series or parallel? Parallel. So what is the common voltage? Or what is the common effective capacitance? Parallel means I can replace the single capacitor. What is it? Plus minus 3C. And what is the charge? What is the charge? Equivalent charge will be how much? Equivalent charge will be how much? 3Q. Understood? Now connecting with the resistance. What is the resistance? A single resistor. What is it? 2 R and 2 R both are in series or parallel. That means what is equivalent resistance? That means simply it becomes a RC circuit. So they're asking what is heat dissipation? What is heat dissipation? What is heat loss? How much of energy is stored in the resistor? How much of energy is stored in the capacitor? Q square by 2 is how much of energy is stored? 3Q whole square by 2 into C. C is how much? 3C. That is 9Q square by 6C. That is how much? 3Q square by 2C. That is the amount of energy stored initially in the capacitor. As soon as I connect a resistor, what will happen? The whole charge will be dissipated. That means whole energy will be dissipated. That means how much of energy is lost? Listen. Okay. So initially there is a two capacitor. Because of these two capacitors, I am assuming a single capacitor. I got it. He got equivalent capacity. These two are in series or parallel. So I got it. 3C. And what is charge? Positive is connected with positive, negative is connected with negative. Charges will be added up or subtracted. Add. So Q plus the 2Q how much? Get out. Clear? 3Q. Now these two ratios also in parallel. So 2R by 3. As soon as I connect them, then what will happen? Whatever the energy stored in the capacitor that will be dissipated. That will be dissipated in the form of heat in the resistor. So how much of energy will be dissipated? How much of energy will dissipate? Whatever the energy present, that whole energy will be dissipated. So what is the amount of energy present in the capacitor? Q square by that is Q is 3Q, C is 3C. That means what is the amount of energy present initially? 3Q square by that is the amount of energy present. The whole energy will be dissipated. So what is the amount of energy lost? That's all, completed. 14th question can you solve? 14th question can you solve? 15th question. A long solenoid. For a long solenoid, what is the magnetic field formula? Mu dot Ni. What is N? Number of turns per unit length. So they gave in the question itself, they gave you that 1000 turns per meter. That means what is small n? 1000 completed. Question number 16. Now you say me. They're asking us to find the ratio of the magnetic to electric interaction of the protons. Then power? How you got it? V is equal to completed, correct. So two protons are moving parallel to each other with equal velocities. The velocity how much? 3 into 10 power 5 meters per second. Now the ratio of the magnetic to electric interaction of protons. See here now, listen everyone. Do you remember this one? If electric field is acting, listen. If electric field, the magnetic field on the velocity, if the three are perpendicular, mutually perpendicular, then the force because of electric field, both the force because of magnetic field, both are equal. Then the charged part will go without any deviation. Do you remember that? That means if these are two proton particles, listen now. These are two protons. They are going without any deviation in a straight line. Why they are going without any deviation in a straight line? Because electric field because of this proton here, the magnetic field because of this proton here, both are in such a way that the net force acting on the particle will be 0. That means E by B is equal to V, velocity selected. I gave you in the notes. So what's the answer now? No, but we can't do it. Okay, wait. There is any relation between the charge, velocity, and current? Charge, velocity, and current. Any relation is there? Let me know. Any relation is there? Okay, we'll keep aside, no problem. We'll see at last. Now, 17th question is same whether you can solve it or not. This one also notes question. Same whether you can solve it or not. This is A. Then this also has to be A. If this is B, then this also has to be B. Now, the same what is equivalent resistance? All the resistances are in parallel. That means what is equivalent resistance? What is equivalent resistance? Array last bench, just 20 minutes. I'll leave you. Let me complete this paper and I will send you. So now 17th question is same. Between A and B, one resistor is there. Again between A and B, one more resistor is there. Again between A and B, one more resistor is present. Again between A and B, one more resistor is present. Again between A and A, one more resistor. Wait, one more point. Here A won't come. Why A won't come? Resistor is present. If it is a wire, then I will take this one as A. So you can't take like that. So I'm assuming this one as X, this one as I'm assuming it as Y. So between Y and X is same, how many resistor is there? One resistor is there. Between X and B, between X and B, one resistor is present. Between A and B, one more resistor is present. This one. Between A and X, one resistor is present. Between B and Y, one more resistor is present. And between last one, A and Y, one resistor is present. So that's what the circuit is. So can we simplify it? That is important. So what we can do now? Galvanometer, Wheatstone bridge. Now think of it. Wake up. Now, how can we solve this question? Think on Sammy. So forget about this R first of all for some time. So remaining is saying how the circuit is. How the circuit is. A, B, X, Y. Between X and Y, one resistor is present. Between X and B, one more resistor is present. Between A and Y, one more resistor is present. Between B and Y, one more resistor is present. Between A and X, one more resistor is present. Now how it looks like you? It is nothing but a. How it looking like for us? How it is looking for us? Yarvana. Samikshana. Anyone is a Samiksha? Anna class? 11th or 12th? SW03 on the side. Office Pakatra. Now between A and B, one more resistor is present. So already we know this is a V-Stone bridge. So I can remove this resistor. So now it becomes easy. R plus R how much? 2R. R plus R how much? 2R. This is R. This 2R and 2R both are in. That is R. R and R both are again in parallel. So what is how much? R by 2. Clear for everyone? So whenever you are unable to solve any circuit, that means simply there must be either a symmetry concept or there might be either some V-Stone bridge. We have to check for it. Clear for everyone? I am unable to solve this question. Why I am unable to solve? Because there is somewhere I have to verify whether this V-Stone bridge is present or not. Once if we got it, then I can remove the resistor because R1 by R2 is equal to R3 by R2. I can remove the middle resistor. Last second bench, call him, call him. Get up, bro. Last second bench. Last second bench, get up. See me the answer for this 20th question. Everyone think of it whether you can solve it or not. The mg is acting vertically downwards. That they told that it is in equilibrium. When the body is in equilibrium, you say me. This is what is the force acting along the plane? mg sin theta. Perpendicular to the plane, what is the force acting? mg. They told what they told in the question. If the sphere is in equilibrium, if the sphere is in equilibrium, then they're asking us to find what is the magnetic field value. So when the sphere will be in equilibrium and downward force is present, there must be some upward force. That is a force because of magnetic field. So now find the value of it. The magnetic field is in which direction? Which direction the magnetic field force will be? Now observe carefully. Now let's see this question carefully. Okay, now see here. Now see here. Now there is a coil, there is a ball, and around this ball, I rounded a coil. There is a current carrying coil. So this is a current carrying coil. Okay, that is a magnetic moment. And now this is a magnetic field. Okay, so what is the torque? The torque is given by the formula mb sin theta. What is theta? Theta is angle between the sin alpha. What is alpha? Alpha is angle between the m bar and p bar. So in which direction this angle is how much? This is theta. So what is the angle between them? MB sin theta. That is a torque. There is a torque acting on the coil. Everyone will accept that. Now what is the torque because of the gravitational force? What is the torque because of gravitational force? The torque because of gravitational force is how much? The torque because of gravitational force. What is the torque because of gravitational force? So if net torque is zero, then I will say the body is in equilibrium. Understood? So first one torque I got because of the magnetic field. There is a current carrying loop. Okay, there is a current carrying loop. What is the torque acting on it? MB into sin theta. Now I want to find what is the torque because of gravitational force. Same. Now you say me in which direction the magnetic force torque will be. The torque because of magnetic force is how much? About this point. Say me now. Say me the answer fastly. Think and say me. What is the torque because of the gravity? MGR? MGR sin theta. Why? MG sin theta into 2R. Why? Hmm. Say me now fastly. Online students, anyone? So what is the torque? One torque is because of the magnetic field. So other torque will be because of the gravity confirm. So what is the torque value? How much? Array? Aishwarya, what is the torque? What is the torque acting on the coil? One torque is because of magnetic field. Another torque because has to be because of gravity. So what is the value of the torque because of gravity on the coil? Or you can assume this is a M bar. No problem. Anything you will get the same answer. Now you say me. How much? Friction is not there. That is not only a coil. Listen, that is not only a coil, that is a sphere also. There is a sphere of radius r and mass m. So if I place any sphere on the surface, so now you say me what is the gravitational force acting on it? This is a sphere. So that is what is the force mg, and what is the perpendicular distance about this point you say me? R. So that is the torque. Because of the torque, it may rotate about the end point. Now what is the another torque? There is a torque acting on the coil. The torque acting on the coil is nothing but the torque acting on the sphere also, because both are attached. How much of torque is acting on the coil? That much of torque is also acting on the sphere. So in which direction? That is important. In which direction the torque is acting? In which direction the torque is acting? The torque is given by the formula R bar cross F bar. That means R bar is this side. The R bar is from the point, this is axis, this is R bar, this is F bar. So R bar cross F bar means one torque is acting that side. That is the torque acting because of gravity. Another torque acting in which direction? M bar cross B bar. M bar is in which direction? M bar is in this direction. I'm rotating the fingers in the direction of B bar. But another torque is in which direction? Towards. One torque is into the plane, another torque is outside the plane. Both are equal. The net torque. Easy. Completely equate them. Equate them. Sin theta cancel out. So mgr must be equal to mb. M is nothing but ia into b. So what they're asking us to find? B value. mgr by ia. Ia is nothing but pi r square. So mg by I pi r. 19th question. Red torque always acts along the axis. Remember that. 19th question. Now it is a Wheatstone bridge or not? It is a Wheatstone bridge or not? R1 by R2 is equal to R3 by R4. It's a balanced bridge or not? 100 by 50 is also equal to 10 by 5. 1 by 2 is to 1 by 2 by 1. One is balanced bridge. What they are asking now? Current to the completed. How much? 0. 30 questions are there. 21. So one magnetic field is because of the wire. Because of the wire, the magnetic field will be in which direction at the center of the coil? Use the direction, right and thumb rule. Because of the wire, the magnetic field is inside. Because of the circular coil, magnetic field is in which direction? Outside. If both are equal, then what is net magnetic field at the center of the coil? 0. Can you solve it? But because if infinity was the magnetic field, mu naught I by 2 pi r. R is how much? 2r. If that is also equal to magnetic field because of the coil, what is magnetic field because of the coil? Mu naught I2 by 2r. So what they're asking, what is the value of I1 by I2? Can you find it? So what's the value of I1 by I2? 2 pi is m pi. That means m value is how much? Silly question. Question number 22. The original length of the resistance is how much? The wire is having resistance of 1 ohm. Now they stretch it 3 times the original length. If it is stretched by 3 times, then that means resistance will increase how many times? 3 square. That is how many times? 9 times. That means resistance becomes how much? I know. 23. Now there is a cylindrical wire of radius how much? There is a cylindrical wire of radius is given, conductivity is given. Now is subject to electric field of how much? 10 millivolt per meter. Electric field is given. Rho is given. Radius is given. The electric field is given. They are asking us to find the value of current is how much. What is the current formula? What is the current formula? What is the current formula? They are asking us to find the expected value of current in the wire will be how much. So whenever apply electric field, the charges will start to move inside it.
A is equal to I by A.
Current density is equal to sigma into electric field. Do you remember this? What is the current density? Current density is nothing but I by A. Conductivity is nothing but 1 by rho. So that means current I is equal to how much? E by rho into A. Right? Do you remember this formula? Current density is equal to sigma into E. Do you remember this? So current density is nothing but current by area. So what is the current? Sigma E by A. They gave resistivity. Resistive conductivity here. They give conductivity. So conductivity is given, electric field is given, area is also given. Can you find the current? Can you find the current? Hey, can you find the current in this question? Yes. Question number 25. There is a wire. What is the shape of the wire? A sine shape. A constant and static magnetic field of 2 Tesla exists perpendicular to the xy plane. X, Y. Magnetic field is inside. Now what they are asking us to find? The magnitude of the magnetic force on the wire PQ is PQ. Where is the PQ? Right? This wire. They are asking what is the force acting on this wire. How much of current passing through it? 1 ampere. So how much it will be? What is the effective length? I don't care what is the length of the wire. I'll only bother what is the force formula. BIL effective. Understood? Remember this. Effective length is starting from P to Q. So what is the length of this? What is the length of that? 4. The effective length is 4. The magnetic field is how much? 2. Current is how much? 1 into 4. That is how much? That's all. Silly. Question number 26. 2T means 2 Tesla. 26. Question number 26. Question number 26. They're asking us to find the voltage of the E. So what the question is? They told that potential at point A is exactly equal to the potential at point B. That means the terminal voltage of the cell is how much? The terminal voltage of the cell is how much? 0. Understood? So that means VA, listen, important. VA, I'm moving from positive to negative. So minus A plus era. Minus E. If this is minus, then IR has to be plus. IR value is 4. Must be equal to VB. They told V and VB both are equal. So that means E must be equal to how much? 4I. Equation number 1. But I don't know what is the current. So take the KVL again. Assume in the branch what is the current? What is the current in the branch? What is the current in the branch? I. So what will you get? 30 plus E by 10 plus 4 plus 2. How much? 10 plus 4 plus 2. 16. So in place of this we can keep the so much 30 plus E by 6 into 4. Equate them, you'll get the E value. Okay. 27. 27. So the current only passes through which branch? The current always prefers to pass through which branch? This branch only, because the current won't pass through the capacitor. The DC current will never pass through the capacitor. A steady state. A steady state when the capacitor is fully charged, there won't be any current. So what is the current in the circuit now? You say me. What is the current in the circuit? E by what's the resistance? R plus R how much? 2R. That is the current. That is 4 by 2R. That is 2 by R. That is the current. So the always the voltage across the capacitor is always equal to the voltage across its end. That means the voltage across the capacitor is always equal to the voltage across this resistor R. What is it? IR. That is 2 by R into R. That is how much? 2 volts. So the voltage across the capacitor is how much? 2 volts. What is charge? What is the charge? Charge is equal to CV. That is 2 into 5. That is how much? Completed. Understood everyone what I am doing here? As they're asking what is the charge on the capacitor in steady state. In steady state, what is the current passing in the capacitor? Zero. That means the current only passes through this circuit. Understood? So what is the current? Current is voltage. Voltage by what is the resistance? R plus R how much? 2R. That means the current in the branch is 2 by R. The voltage across the capacitor is always equal to the voltage across this branch or voltage across this resistor. Do you remember this? The voltage across the capacitor is always equal to voltage across this branch. That means voltage across the small r is how much? I into R. Remember what is the voltage across the capacitor? 2 volts. What is the charge? Q into V. Q is equal to C. 10. 28 easy. 29 also easy. 30 also easy. Are in this whole paper, just if you revise the notes, how many you may feel difficult? How many questions you may feel difficult? Maybe 5 questions, maybe. Than that, I think if you revise the notes, surely I believe that you won't feel more than that. So I want in next exam everyone to get at least out of 100, minimum 70. Minimum. Make sure that you are doing the questions correctly. Don't do calculation mistakes. Understood? You can leave your online students.
Thank you, sir.
Thank you, sir.